Alright, this is the video for electric fields. Where can I put this? Maybe over here. And we're going to start with a review from the fall semester. And if we have two planets of the same mass, one's this far from the sun and the other is twice as far, how is the force of gravity between B and the sun compared to A and the sun? And the first thing you need to remember is, number one, it's farther away, so we know it's weaker, so we know these two aren't the correct answer. The second is, well, we use this formula, and we know that force of gravity is inversely related to distance squared. That means if it's twice the distance, then you have to invert it and then square it. 1 squared, 2 squared equals 1 over 4. So if you double the distance, gravity is only 1/4 of the original force. And we're going to actually use this idea a lot today. What we know so far is that atoms are made of positive protons and negative electrons. Neutrons are neutral. Opposite charges attract and like charges repel. An object becomes charged when there is an unbalance of positive and negative charge. The bigger the difference, the greater the attraction. There's lots of really cool demos we did with the Van de Graaff generator that we're not going to be able to do because we're online. Today, charges create electric fields. The more common charge, the stronger the field. Work against an electric field can create electric potential. So, electric fields. Part of your basic stuff is to draw electric fields. So, let's draw some electric fields. We're not going to watch the video, so I'm just going to draw them, and you can fill them in the box if you're doing these notes. Maybe if you're just reviewing, just follow along. But a positive point charge has an electric field going out. So positive point charge fields go away, and you draw that in this box. Negative point charge fields come towards it. And if you have a positive and a negative together, it's going from the positive to the negative. If you have a negative and a negative together, it's coming in, but it won't try to touch each other. So they'll just come in like this. And this is the source of all repulsive force. If it's a positive and a positive, then it's the same, only the lines are going out. Because field lines go away from the positives. They kind of look like this. Here is shavings of metal suspended in oil with an electric current going through it. And you can see these are like charges because they're coming together. Sorry, these are opposite charges. Opposites attract. And these ones are like charges, maybe both positive. And they want to come together, but then they start pushing away. So here's your test question. Diagram an electric field between the 2 point charges and predict how they will move if released. So try this question, and then here's the answer. For positive and negative, the lines are going from the positive to the negative. And then here we have after opposites attract. They'll be closer together. If it's maybe a positive and a positive, then they'll be coming out but not touching because they repel each other. And afterwards, they will push each other away. Okay, copy down this and we'll add the new force formula. Gravity is the force of gravitational strength. It's always attractive, increases with mass, and is inversely related to distance. This formula, force, is this K. This is a constant. It's just a number. We'll learn about it when we do the advanced. Times charge 1 times charge 2 divided by distance squared. It's attractive or repulsive. It increases with charge, and this one's the same. As the distance between charges increases, the force decreases. As they get closer together, the force gets stronger. So here's practice problems. How does the factor of this change? So remember your inverse distance law. As things get closer together, the force gets stronger. So 1/3, invert it, square it. Factor of 9. Here's what your test question will be like. Try to answer it. Here comes the answer. Well, I know that it's getting closer together, so I know it's not getting smaller, it's getting larger. And now I do my inverse law, invert it, square it, equals 4. Okay, electric fields store energy. So imagine we have a bunch of charge here and one little guy. Well, if we try to pull him away, we get potential energy, just like when we lift something up. If this guy were to fall back down, it could do work. And this falling, this being drawn towards the opposite charge, is what happens when electricity runs through a wire. It's being drawn together, and this movement can do work. And that's how we light things up. So what we have is voltage is the total difference between positive and negative charge that a charge feels. That's too big. It's like potential energy, but it has to do with the difference, so we call it potential difference, or voltage. It's the same thing. So you need to explain how this battery works. We have this difference. These guys want to get together and they can't. So if we connect them, now they can start coming together and the battery dies. So if it's connected, these guys can travel along the path and do work. And when the net charge equalizes, then the battery is dead. So your question is to try to explain how this happens. Explain and diagram how a battery has the potential to do work using the following vocabulary: opposite charge, potential difference, and voltage. We'll answer this on Monday.